The Bibites is an evolution simulation I've been working on for, 5 years now. The simulation has grown a lot from its humble beginnings, and I think that the project is way overdue for a showcase of how it works and what kind of complexity you can expect from it. After all, you can download the simulation for free on itch.io and observe your own unique universe. In this video, I'll try to do that and let the simulation run for 100 hours and see how things develop over time. Because not only do their genes mutate over generations, their brain too. And with a lot of senses and actions at their disposal, their behavior is always unique between every run. We'll try to explore things from the perspective of taxonomy, biology, ecology, and all the other science we can fit in there. So, without more delay, welcome to the fascinating world of the Bibites. So, the first thing to note is that you have a lot of control over the parameters and the rules of the environment. You can alter how plants grow, how hard it is to move around, the energy cost of producing pheromones, and oh so much more. In fact, you have access to around 120 settings that influence the simulation. In our case, we'll keep things pretty normal. We'll keep most settings as default, but I'll play around with the plant spawning settings to make it so that we have 3 different and isolated plant islands on a fairly big map. As a result, we'll be able to see distinct populations develop on each island, and I think that this will make for a more interesting video. By default, the islands slowly drift around, but I'll make it a little slower so that the islands stay distinct and don't run into one another. That being said, let's go in. Awesome. We have our 3 islands, each with a large number of plant pellets ready to be colonized. Right at the start, basic Bibites with some degree of variations are spawned. Most are unadapted for this environment, and it will take some time before real species start to develop and survive on their own. In this case, the islands are pretty small, so it's easy for Bibites to run into the void and die before they reach maturity, especially if they are fast. Additionally, their energy budget is pretty tight at the start, so going too fast would be too costly for the speed at which they can digest food. After approximately half an hour in, we have the first Bibite that managed to lay an egg on our southern island. They managed to do this by moving really slowly to conserve energy and prevent running into the void. They also turn toward where there's the most amount of food, so that's always useful. As such, they get the honor of being the first official species. Because of their beautiful, cute eyes, we'll name them Rosoculi primitus, for the initial pink eye. By the way, I have to tell you right now that I'm not a trained biologist. Everything I'm teaching you now, I learned on my own, and might have learned wrong. That being said, let me tell you things as if they were facts. The binomial naming system is the system used to give scientific names to species in what we call the field of taxonomy. Basically, all species are given a name composed of 2 terms. The first is called the generic name and identifies the genus of the species. Genus just basically means group. The second part is called the specific name and is used to differentiate the different species inside a genus. Back to it. After some time, other species have started taking hold on the other islands, using similar adaptations like being very slow and boring to watch in real time. But they are less unique and not as cool as our Rosoculi, so we'll wait a little bit before naming them. Fast forward to 7 hours in, on the eastern island, we have a few notable species. First, there's these guys that are rather odd looking. I think the species name Stultus apparere, for stupid looking, is fitting. Alongside them, we have these purple-eyed Bibites that have a funny mutation. They evolved the connection toward their immune system neuron, which is unused in this simulation since I did not enable the virus system in this run. So as a result, we'll name them Inutilus cascus, for the original useless. On our western island, the most prevalent species is this one, which has evolved a bigger size than most other species so far. This seems to help them gobble up smaller plant pellets without having to bite into them, which is an early form of filter feeding. For them, Pingus paulum, for somewhat fat, fits perfectly. Back to our southern island, where Rosoculi is thriving, their behavior is still relatively the same, beside minor changes to their genes. After all, we've only just reached the 8th generation, so they don't vary too much for now. One thing I dislike, however, is that some of them have started to diverge and evolve slightly different hide colors. I just named the species after this exact feature. So if this keeps happening, it has the potential to make me look very dumb. We don't want that, so I'll have to play God a little bit and cleanse the members that differ too much from our ideals. And a while ago I added a button to do just that. But we have many means of achieving that same goal. However, after not even an hour I got very tired, which started to put quite a strain on my carpal tunnels. I had some discussions with Aleholab, the creator of another evolution simulation that focuses on plants. He recently implemented something along those lines and suggested I do the same.
Yeah, I recently implemented something along those lines, and I suggest that you do the same. Let me show you. This sphere in the middle is the target color, and all these colors you can see around are within the tolerance range. Then I have created this laser tower that kills automatically any plant that is very different from the target color. I will explain it better in my video. I will explain how I made it work. And maybe you, for the Bibites, you need to do something slightly different. You good? Okay.
Alejo was right. Obviously, the best idea was to automate selection. I got to work, and after some coding, I ended up with an awesome result. You can now place the color selector and tune its parameters to produce the exact behavior you want. In this case, I'll choose the right hue and define a small tolerance. I'll select the right parameters, and voila! Nice, so we should be good to go. I'll leave the simulation running and see where it lands us. 15 hours in, things have developed in an interesting manner. Our Rosoculi primitus have separated into two species. The first still has a pretty similar brain, but has started to grow a little bit. Their size gene went up by a significant, but still small amount. We'll name them Rosoculi paudomagis, for a little more of pink eye. The second species has a lower speed gene, but evolved a more complex brain compared to their ancestor and cousin. Most notably, they started to produce pheromones proportionally to how full they are. They do not sense the pheromones in any way, but now that pheromones are present in the environment, it could evolve at any point in the future. That's usually how the use of pheromones evolved too in the animal kingdom on Earth. First, a random mutation makes a species produce a certain odor, and further down the line, others might have an evolutive pressure to be able to recognize that scent and use it for a specific purpose. Then, they also have the incentive to produce that pheromone in greater quantity, essentially being a positive feedback loop of pheromone development. For that reason, we'll name these ones Rosoculi benolet, for good-smelling pink eye. On our eastern island, things are dire. All the Bibites seem to now be pink-eyed too. Looking at their brain and genes, it seems like they are all descendants of Inutilus cascus, that just happened to develop pink eyes and are not at all related to the Rosoculi species of the south. Looking around, it also looks like the Stultus aparere species was wiped out. They were stupid after all, so it kinda makes sense. The Inutilus genus split in two notable species that look identical but have pretty different brains and behavior. The first one evolved to digest things slower as it ages. This seems to allow them to be more efficient as they age and need less energy for growth. The name Inutilus canosalvus, for useless aging stomachs, is good enough. Their cousins on their part have started to turn as their stomach fills up. This seems like a helpful way to stay around places that have a good amount of food. In fact, after watching an old video from Divergent, I recognized this behavior was a form of indirect kinesis, a non-directional change in activity in response to a stimulus. Basically, if they turn when they manage to eat food and have a full stomach, they are more likely to stay in the same area and profit from the same food source. In our case, this seemed like a very good additional safety against running out into the void. As a result, they'll get the perfect name of Inutilus turboplenus, for useless that turns when full. And finally, on our western island, the big Pingus paulum disappeared in favor of their descendants. They have grown even larger and have a mean look in their eyes. We'll name them Pingus avarus, for greedy and greasy. And whoops! I forgot to pause the game overnight and we accidentally jumped 15 hours in the future. We are now 30 hours in and very interesting things have happened. First of all, our southern island is now populated by big greenish creatures. They are big and slow and seem to be the first direct observation of filter feeding so far. The older and bigger individuals open their mouths as much as possible and directly swallow all the food they run into. However, when trying to classify them, I run into a little bit of difficulty and I'm getting quite confused. First, they seem to share a lot of the genetic markers of Rosoculi paulomagis, and we could even say that they follow a natural progression as paulomagis had already started increasing in size. However, if we look at their brain, they share a structure that is very similar to what Inutilus turboplenus from the eastern island had. In fact, putting them side to side, the similitude is pretty evident. As a result, I'm having a very hard time figuring out what species is the ancestor of our green giants here. Are they from the Rosoculi genus and just a result of lucky convergent evolution? Or are they from the Inutilus genus that migrated across the void, colonizing the island and wiping out the local Rosoculi population and also happening to lose their characteristic useless connection? I tried calculating the probabilities of both options, and both ended up being very unlikely and of similar proportions. Well, now you can see how being a biologist and trying to classify species can be a very hard endeavor. I think that based on the fact that our green giants have a gene that has the exact same value as Rosoculi paulomagis had 15 hours ago, I'm going to put our giants in the Rosoculi genus, as descendants of the paulomagis. I might also be influenced by the fact that I don't want the Rosoculi genus to be extinct already, but this is a very hard call to make. We'll give them the name Rosoculi major because of their size. Moving on from that conundrum and onto the western island. The dominating species is still extremely similar to what we had 15 hours ago. Inutilus turboplenus stays pretty much unchanged. As such, we'll name the present one Inutilus turboplenus cordi for the second Inutilus turboplenus. I'll probably keep that framework and give the cordi title to species that don't change much after a long time. I want to say, however, that this is probably not standard practice. I don't know what I'm doing. On our western island, we find that a lot of plants seem to have accumulated, creating a lush and abundant environment. I'm not very sure how that happened, since food should grow similarly on all the islands. Probably a bug. Looking at the actual inhabitants of this island, we see cute red-eyed Bibites that should be the descendants of our Avarus. Wait. Oh god. Looking into it more, these ones are definitely from the Inutulus genus. They have the exact same brain structure and the same useless connection that characterizes them. This proves that Inutulus turboplenus has migrated at least once. They managed to survive the trip through the void and reach the West Island, where they took hold, reproduced, and eventually wiped out the previous native population of Pingus avarus. We'll name them Inutulus proculis, for useless from far away. The fact that we now have proof of an existing migration event might make us rethink our classification of the green giant population. However, the fact that all members of the Inutulus genus stayed this simple and didn't vary too much makes me think that it would have been less likely for them to evolve so differently in the southern island. I've never been this uncertain of a choice in my life, but I'll keep my decision and leave them as members of the Rosoculi family. Moving on, and whoops! Again, I've managed to forget the simulation running overnight. We are now 20 hours later, at 50 hours into the simulation, with no save files in between to go to and help us make sense of how things have developed. This is akin to how paleontologists might have a lot of information missing from certain periods of the fossil record, and it will probably complicate our process a lot. I'll try my best to be better and take more regular and frequent saves of the simulation from now on. So, 50 hours in, and our western island still seems to be more fertile than the others. The population there looks very chaotic and displays a lot of variety in color. Looking deeper into it, I think I managed to identify 3 distinct species that are different enough. They are not too interesting, so I think that I'll name them quickly Inutulus unus multum 1, 2, and 3, for one of the many useless 1, 2, and 3. Looking at the situation in our favorite southern island, things are surprising. We have 2 very different and identifiable species. One displays a flashy green body and a dangerous-looking mouth, indicating a high-strength gene that would result in higher damage when biting. The other one is way paler, but instead has started growing armor and defenses. They also produce green pheromones when seeing other Bibites and leave beautiful trails behind them. Just to be clear, however, they are both herbivores, which can be seen through the shape of their mouth. However, they have plenty of other differences that we can look into. If we now look at the growth genes, we can predict that their growth curve will look pretty different. The growth curve of a species just describes how fast they grow over their lifetime. And while they can look quite complex for species we find in the real world, in the Bibites, that curve is defined by those 3 genes and a far simpler formula. If we compare our 2 species here, we can see that while their growth start at a similar level, they quickly diverge, with the paler one growing approximately 2 times slower. Also, it's interesting to note that both species will continue growing all their lifetime, even after reaching maturity. That doesn't have to be the case, as the formula allows for a large variety of curves. Those differences surprise me because a higher strength makes growth cost more energy, so in the case of our flashy ones here, not only do they grow faster, their growth is also more expensive. This is somewhat balanced by the fact that their size gene is a little lower, and they also have a slower metabolism. But still, I found that surprising. If we compare the energy costs of 2 individuals that are approximately at the same stage of growth, we see that the paler species uses a lot more energy overall, especially for sustaining their metabolism. But our flashy ones just have more energy diverted to growth. So, faced with the same environment, they seem to be going for very different strategies in managing their energy. I think it's going to be very interesting to see this dynamic develop over the next generations. We'll name them accordingly Rosoculi infensis for aggressive pink eye and Rosoculi rigicutus for tough-skinned pink eye. Now going to our eastern island, we see an interesting situation. First, we have these, which are rather odd-looking, and somewhat familiar to a species that inhabited that same island not too long ago. However, studying the genome and brain of that species, they are clearly from the Unutulus genus. They just seem to have diverged a lot from their ancestor, which is not too surprising considering the huge gap since our last study. As an homage to the past, we'll name them Inutilus stultum, for useless and stupid. The other species inhabiting this island also looks quite familiar. In fact, by reviewing their brain structure and genes, they are definitely Rosoculi descendants. Even more so, I think I can safely assume that they migrated from the southern island quite a while ago, before the two species we now have there started diverging. They share brain structures that this migrator doesn't have. They are in far greater number than the Stultums, suggesting that they have slowly been taking more space and slowly driving them closer and closer to extinction. As such, we'll name them Rosoculi ostis, for conqueror pink eye. This video is already getting a lot longer than I first anticipated, so I'm going to stop things here and rush the second part. At the time at which this is uploaded, I'm already mostly done and will do my best to finish and upload it within a week. I don't want to leave you waiting for too long. I'm going to announce a big event at the end of the second part, so make sure to subscribe to the channel and ring the notification bell to get to see the video early. And I know I left the video on a big cliffhanger with our two competing strategies on the southern island, but aside from forcing you to watch the next part in order to get closure, I think that this is an opportunity to let you, the viewer, place your bets and try to guess how this situation will develop. Let me know your theory in the comments and I'll draw a Discord key at random amongst the comments that were right, allowing you to join the private Discord server where my Patreons and I are active. So thanks a lot for watching, and I'll see you very soon in the second part of this adventure.
Bye.